Namaste everyone. Our today's session, as we know, it is on software engineering lecture process models. Okay, uh, we are going to revise the software engineering life cycle. I'm trying to be a bit interactive, not a normal PPT. So SDLC, software development life cycle. Okay. So for our software engineering subject, this topic SDLC is very, very important. Okay, because it tells you the from start to the scratch. So we will just revise of what we took last time. So our first phase is your requirement gathering. Second phase, if anybody wants to speak, you can. So second phase is analysis. Okay, because of this approach, I'm going a bit slow. So if I speak fast, maybe this SDLC lifecycle is a very important thing. Okay, so it might skip. Third phase is design. Then implementation / coding. Then next is testing. And in a long-term project, you also have maintenance. Okay. So these are all the dabbas of a train which we need to connect. So the first connect will come from the client, because in requirement gathering, we will try to find out from the client, okay, or if you're working in a company, if you are doing a mini project or a major project, whatever project we are doing, we should know who will be our stakeholders, who will be our users, correct? So that users, stakeholders, clients, okay, you can just mention in your notes. Okay, you can make notes, and here you can just write down from where you can get clients if you are working in a company, or users, or your stakeholders, investors, etc. Okay, so this year your input will come. That is very, very important. Okay, SDLC makes three things very clear. What is the input? What is the process you're going to do? Okay, which will make your implementation faster, and in testing it can be debugged, and giving the end product to your client, and the output which is expected by him or her. So so
Hello, ma'am.
what three things are important? Very, very
Hello.
important. Uh, Three things are important. I'll mention here: the input, process, and output. So if you do not know what is the output, why are you making the project, first of all? Okay. Secondly, for the output, what will be the input? So input can be an image. Input can be, for example, now I'm teaching a lecture. Okay, so my output is to deliver SDLC life cycle in this short session to my students. So this will be my input. Sorry, this is my output. For the output, what is the input? The input is this teacher who is going to deliver an online session for this. Now, what would be the process? The teacher might use this whiteboard or some PPT to present, which we already did last time. Okay, or I can do the chalkboard if it's an online lecture, offline lecture, and so on. So I need to understand what process I can use so that my output is achieved. Okay, now for this particular output only, to deliver a lecture on SDLC lifecycle, lot of processes can be used. I can create an audio and share it to you. Okay, I can share a YouTube video of somebody else to you, or whatever I'm doing right now, or if I'm taking an offline lecture, okay, maybe I can use a chalkboard or whatever it is. So this is the process. But the main point is processes can be different. And some processes may be good, maybe bad, maybe failure. It all depends upon the context. But the main important is you need the output. But for the output, what is the input? So if the client tells you the input which is going to come would be in the text format, but you made the process SDLC lifecycle that the input is an image. So obviously the output would not be expected. Even if the output is expected, whether I'm getting input as an image, no, because client told you the input would be text. So this is very, very important. So what is the input? What is the input to the requirement gathering of the SDLC cycle is the input which will be coming from the clients or the users or the stakeholders. Is this point clear to you? Then what will be the output? So the output would be, okay. Now, if you use ChatGPT or other GenAI models or maybe book, they might tell that SRS is the output. I don't think SRS, it would be too early, okay, to write here. But yes, in some projects, if they are big brands, okay, they might land up to creating an SRS at this phase itself. But for me, I generally consider let's have a small achievable output for you students. It will be the process model identification. So in last class, we understood about the waterfall model. So process models, there are a lot of process models: waterfall, increment, rapid application development, that is RAD model, okay, um, prototyping model, and so on and so forth. So we need to understand which model will be apt for our problem statement. Okay. So here, instead of directly jumping to the SRS, I would say the outcome of the requirement gathering will be the process model. For example, we identified that waterfall model is the best for my process model, and we will put that as an input. So now we have got the input. We know who are our stakeholders. We know the process model. And here we will do the analysis. Analysis means we'll be breaking up our problem statement into parts, okay, and doing deep research. And we will try, and I would suggest the output here should be your SRS. Now, SRS is System Requirement Specification. I'll put the description link of my videos on SRS. Now, SRS can be System Requirement Specification or Software Requirement Specification, right? So both the things can be achieved in detail over here, okay? And in our videos, I've also covered what is the difference between both of them. But here, not to make this video too long and complicated, okay, so not to make this video long and complicated, I would stick to only the SDLC input output. So in the analysis phase, you will be deeply going into the inputs, various formats, the process, the process model, the software, the hardware specifications in detail. So that all should consist of the SRS. So that will be the output here. So if it is a software requirement specifications, only the details required specific to the software will be there. But if it is system requirement specification, then hardware will also come in the system. Okay, so if you didn't understood this, just rewind the video instead of I repeating it so that you understand it again. Now here the SRS come as input. Now this SRS will be useful from the client. You can get this SRS signed by the user over here. So you can have an arrow here. You will get it signed so that now this becomes our document verified, where later even the client can't back out that this was the input, this was the expected output. Maybe there can be some argument. So to avoid that and you coming on stake, this will be after this is done entirely. Now see, some people do it at this phase, but some people try to do it at this phase because in requirement gathering, as our previous lecture, project manager is involved, which directly connects to the client. In this phase, the project manager connects to the project leader, and the project leader can connect to the developer and the project manager, and even if required, have a meeting with the stakeholders also if it didn't understood the exact requirement, so that they are in the phase of getting the details done, even if some guidance from the developer side, so that later they don't come to an end that they can't provide the things which the company is not supporting. So that is why it is recommended that the SRA should come up after the discussion with the technical team, and hence it can be verified and signed and authenticated. Okay, so SRA is coming as an input, and here the output would be the design. So design in the form of UML. So I told you last time also, there is one language which generally all software engineers use, that is called the modeling language, which is called as the UML. So UML has all the notations where using visual representation, the entire design in different perspective, the 1D, 2D, 3D, from user's perspective, from the developer's perspective, from project manager's perspective, from stakeholders' perspective, from, libraries perspective. Libraries means DLLs, which we need to install and all that. From all angles, visual representations are created, and that is called UML diagrams. Modeling language, model because visual representation, and unified means it is universe. And then after these designs are there, okay, you can have a use case diagram, class diagram, sequence diagram. We'll have each diagram in detail in our upcoming sessions, and then directly implementation is started because we have all the requirements. Okay, SRS will come here, UML will come here, and the implementation starts. Okay, and then it goes to the testing phase. So what will be the output of this? The source code. Source code, UI, etc. The backend, if needed, the backend also can be there, or whether it is outsourced or whatever it is. Finally, you can say either you will deliver a system which consists of hardware, software, etc., which we call it as, okay, or your product, or your project, whatever. And this will go to the testing phase, correct? The testers will test it from all angles, from the client perspective, from the developers, and will do alpha testing, beta testing, non-technical, technical, okay? And if there are bugs, then it need to redirect again to the implementation team. If the implementation team identifies that, it is a design defect, so it will come to the design. If design defect says no, it is analysis defect. If it comes to this phase, then you can understand there is a problem in this verified document. So this will be a very big stake to the company. So if the defect is over here, still good and recoverable. If it goes here, lot of reverse engineering has to be done on the code. Okay, so that is why these phases have to be well drafted, well documented, and well designed and well planned. Okay, and I told you in the previous lectures that if you avoid these three phases, then you are a application developer, not an engineering developer, because engineering developer goes through proper phases so that such defects don't come out over here. So if you want to avoid such defects and such clashes, these phases have to be done instead of just jumping directly to the coding. And if you have the designs, if there is a debug in the design, you can still rectify in the coding. But if it is without any design, you are writing a 2 lakh code, then you can understand. If you deliver your code to somebody else who leaves the project, okay, people come and go in an organization. All these things will give him a clear picture from where to start and from where to proceed. Fine. So this is all about SDLC life cycle. I think this joining of the dots, these arrows and this DAPA, this train is now complete because we know the input of each. And finally, when it is well tested, okay, it can have a direct system testing on the, which is called a black box testing on the client side. And the client is handed over the project. Okay. If suppose client has some system testing, it will be again reversed. Fine. And finally, when it is trial and tested on even the client side, the product is finally okay for deployment at the client side end. Deployment means then that system will now belong to them and it is executable. So I hope this short session on SDLC lifecycle will be helpful to you. So this is Dr. Aisha Butalia signing off from this short session on joining the dots, okay, or joining these boxes or the parts of SDLC life cycle. You can take this, my session, as a case study where I told you what will be the outcome is teaching you this session. The input is I am the instructor and the processes that I can use to deliver this topic. Maybe, as I did it using whiteboard. I used whiteboard today just to tell you that this is another way of teaching, right? Because we generally use Blackboard or PPT or in offline lectures also. So thank you once again for your patience listening. Have a nice day.